Alright, algebra students, today's video and today's notes are the last notes for the slope unit, and so we will be taking a unit test very soon. So last page of notes in unit 4 about slope, and what we're going to be learning about today is parallel and perpendicular lines. And so the first thing we want to make sure that we understand is, well, what are parallel and what are perpendicular lines? So if you remember back from probably 5th or even maybe 4th grade, parallel lines are lines which never intersect each other and also never intersect. They never cross. They run forever and ever in the same direction, both up and down, sideways, and never intersect each other. So these are parallel lines. Remember, normally they are, sometimes we will denote them with arrows, showing that they go in a parallel direction on and on forever. So this is parallel. And then perpendicular lines, of course, are lines which meet at a exact right angle. So these lines we would call perpendicular. Of course, they don't have to be straight up and down. They could be sideways like this, as long as when they meet, that angle right there is 90 degrees. And actually it's 90 degrees all the way around, right? All of these angles would be 90 degrees. So perpendicular, parallel, never intersecting, always running like train tracks, and perpendicular means that they meet at a 90-degree angle. And so what we're going to do today is just a real quick exploration of parallel and perpendicular lines and what that has to do with and the connection to slope. All right. So we're going to ask ourselves a couple of questions about a couple of different sets of equations. So the first example is going to be, if you have the equation y equals 2x plus 6, and if you have the equation 4x minus 2y is equal to 12. We're going to make a couple of observations about these things. And then the second set, so example number 2, we're going to look at two different sets of equations. So y is equal to 3/4 x plus 5, and then 3y is equal to negative 4x. So we're going to look at comparing and contrasting both of these sets. Again, this is example 1, this is example 2, and we're going to look and see what we can infer about them. Now, we're going to compare these two equations on the left side first. So we've got y is equal to 2x plus 6. So the first thing I want you to notice is, what is the slope in this first equation? The slope, remember, is right in front of the x. That's the m value. The slope here is 2. All right, do we know the slope in this equation yet? No, we do not. We have to have it in y equals mx plus b before we can actually figure out what the slope is. So just really quickly, I'm going to solve this for y. So I'm going to subtract 4x from this side. That means I'm going to subtract 4x from this side as well. We get negative 2y is equal to 12 minus 4x. Then we're going to divide by negative 2. Now remember, when we divide the whole side by negative 2, of course it cancels over here and we get y is equal to. So that's a good sign. But remember, we have to distribute the division here. And so we're going to do, first of all, 12 divided by negative 2, which would be negative 6. And then we're also going to do negative 4 divided by negative 2, which is positive 2x. Now, what do you notice about the slope of this line? Now that we have it in y equals mx plus b, and of course, remember, slope goes in front of the x, and the x, we could switch this around if we wanted to. Y is equal to 2x plus negative 6 or minus 6, if you want to write it back in y equals mx plus b form. But notice the slope here is the same. This is the m value, right? We had 2 in this first equation, we had 2 in this next equation. Now watch what happens when I'm going to bring up Desmos, and I'm going to graph these two equations. So I've got my Desmos here. Zoom out a little bit. All right. So I'm going to type in both of those equations. So the first one was y equals 2x plus 6. That was our first equation. So notice that line. And now the second line, I'm going to type it in just as I was given it. So not the solved version, but just as it was given to me. So 4x minus 2y is equal to 12. Now, what do you notice about these lines? Well, they're parallel to each other, right? And you can zoom out and do all kinds of strange things, zoom out as far as you want to. These lines will never, ever touch each other. They just keep on going in the same direction both ways forever and ever. I'm going to go back home so we can see them a little clearer. Now, notice when we solved this first equation, of course, has an intercept of 6, right? And so we can see that the red line right here crosses right through the y-axis at 6. But notice when we solved, what was our intercept for this equation? It was -6, right? And so if you notice, it goes through, of course, it goes down through the y-intercept here at -6. But what was similar about both of these equations? Oh, why did that get so small? There we go. Now we can see the whole thing. What was similar about these two equations? They both have the same slope. And if two lines have the same slope, well, of course, if they have two different intercepts, they're going to be going up and over at the same rate. And so that's what causes these lines to never cross each other, is the fact that they have exactly the same slope. So one observation we're going to make, and I'm going to continue this line down through the middle so I can separate my examples here. For parallel lines will have the same slope. Same slope. I'm going to underline that. Parallel lines have the same slope. And so if you're given two lines and they have the same slope, even if their intercepts are different, right? Of course, they are going to be parallel to one another. Now, let's take a look at what happens in the second example. So let's look at these two equations. Now, the first one's already solved for y is equal to 3/4 x plus 5. That's y is equal to mx plus b. This one is not solved yet, and so what I'm going to do is I'm going to go ahead and solve it for y. This is pretty easy because all I have to do is divide by 3 on each side. And so the 3's cancel. I'm left with y is equal to, and for this one, I get -4/3x, right? -4 will not divide evenly by 3, and so I just have to write it as a fraction. Now, take a look at these slopes. So the slope in this first equation is 3/4. That is the slope of my first equation. What is the slope in the second equation? It's -4/3. Do you see a connection between them? Well, they both have 3 and 4. This one is 3/4. This one is 4/3. And also one is positive and one is negative. Now, I'm going to graph these so we can see what they look like in Desmos. So I'm going to bring up my calculator again. And so the first equation was y is equal to 3/4. Again, I'm going to type them in exactly as I was given them. X plus 5. And then for this one, I'm going to type in, again, just as it was given to me. It was 3y is equal to -4x. All right, now let's look at what this graph looks like. What's interesting about these? Well, they do meet at exactly a right angle. And if you're ever concerned about something being at exactly a right angle, you can take a piece of paper and slide it in there. And if it meets, that's definitely a right angle. So these are perpendicular lines. Now, what do we notice about the connection between the slopes? Well, perpendicular lines, oh, if I could only spell, that's a P, P-E-R-P-E-N-D-I-C-U-L-A-R. This should be a P, perpendicular. Lines will have, well, what's true about the slope? Again, the intercepts are kind of inconsequential. This one crossed at +5. This one crosses at +0 or +0 or -0 even. But it's the slopes that we're really concerned about. Well, the connection is that these are actually reciprocals. And if you don't remember what a reciprocal is, reciprocal, just for example, let's make a note. Reciprocals are things like, if you had 3/4, the reciprocal would be 4/3. All right, they would be, you just flip it. You learned this when you did fraction division in 6th grade. Keep it, switch it, flip it. You just turned it upside down. So these are actually reciprocals of each other. Not only are they reciprocals, though, one's positive and one's negative. And so what we call this is a negative reciprocal. Perpendicular lines will have negative reciprocal slopes. Negative reciprocal slopes. And so we're going to fill in a chart, and we're going to look at some examples of that. But that's a way of telling from an equation whether a line is two lines are parallel to each other or perpendicular to each other based on their slopes. Parallel lines will have the same slope. Perpendicular lines will have negative reciprocal slopes. So for the rest of this page, I'm actually going to just continue. We should have just split the page in half the whole way. I'm going to make a little chart here. So for the rest of the page, I'm actually going to split my half in half, and I'm going to split my half in half. And so we're going to look at if I'm given a slope. So this is going to be original slope. So slope and slope. Slope this is parallel. This is perpendicular over here. And so the first section here is going to be a parallel slope. And the second section here is going to be a perpendicular slope. Perpendicular slope. Okay? So, for example, if the slope, let's say, is 5/2. If I'm given that the slope of any line is 5/2, what would I know about a line that is parallel to it? What is its slope going to be? Well, it's the same, 5/2. If you are given that a slope of a line is 2, a parallel slope to it is going to be 2. If you're given the slope of a line is 0, what would the parallel slope be? 0. It's going to be the same, whatever it is. If you're given the slope of a line is negative 1/3, then a parallel slope is going to be negative 1/3. Parallel is easy. If you know the slope, you know a parallel slope. It's exactly the same. Now, perpendicular, you have to be a little more careful. So let's look at, well, what if the slope, let's again do 5/2. If the slope is 5/2, what's the perpendicular slope going to be? Well, it's the negative reciprocal. So since this, and I actually probably should have moved this down a line so we can line it up here. So if the slope is 5/2, the perpendicular slope is going to be, it's positive, so it's going to be negative, and it's going to be the flip. So it's going to be 2/5. If the original slope is 2, like it was over here, then the perpendicular slope, it's positive, so the perpendicular slope is going to be negative, and it's going to be the flip. Well, how do I flip 2? Well, remember, 2 is really 2/1, so it's going to flip to 1/2, so negative 1/2. If the slope is 0, what would the perpendicular slope be? Well, remember, 0 slope looks like this, so perpendicular is going to be straight up and down, right? What do we know that as? Well, if you were to flip 0, 0 could really be divided by anything. If you put 0/1, that means the perpendicular slope is 1/0, but 1/0 is really just undefined. Just going to put UND for undefined. And if the original slope were negative 1/3, then I'm going to, again, make it the opposite, make it the negative. And the opposite of negative is positive, and I'm going to flip this 3/1, which is actually just 3. So the negative reciprocal, you flip the number, whatever it is, and you make it the opposite sign. If it's positive, it becomes negative. If it's negative, it becomes positive. All right, so those are the connections between the slopes of those lines. So that is one part of what you're going to need to know, these definitions right here about the slopes of parallel lines and perpendicular lines. Now, we're going to go to the next page because we are going to work some examples where you are going to have to find some new equations of some lines. So, the steps, and so we're going to talk now about finding parallel and perpendicular equations. And we're just going to view a few examples of these. So finding parallel and perpendicular equations. And here are the steps. So step number 1, you're going to find the slope. It's the slope that we're concerned about because it's the same slope that makes it parallel, and it's the opposite reciprocal slope that makes it perpendicular. So we're going to find the slope of the equation. Then step 2, we're going to find the new slope. And of course, that's either going to be parallel lines, I'll just make parallel symbol there, or perpendicular lines. find the new slope. Then we are going to use point slope form to write equation. And remember, that is y minus y1 equals mx minus x1. We're going to use that equation to write a new equation. And then step 4 is going to be solve for y equals mx plus b. And of course, that's slope intercept. Now, that may seem like a lot, but it's gonna make a whole lot more sense once we go through these 4 steps. We're gonna find the slope, find the new slope based on whether it's asking us for parallel or perpendicular. We're gonna use point slope to write an equation, and then just like we did in the warm-up today, we're going to solve this and put it in y equals mx plus b. You want your answer, when you're doing parallel and perpendicular lines, your answer is usually going to be written in y is equal to mx plus b, so we just need to be able to transfer between the two. All right, so we're going to do 4 examples. So draw the rest of your paper. Go ahead and split it into 4 equal sections. And so the instructions will look something like this. If I were you and you were me, I'd be writing pretty small about right now so we can fit all this in here. All right, so the instructions might look, and I'm going to go over into to give myself plenty of room, over into the margin. So write equation of a line which is parallel to y equals negative 2x plus 5 and passes through point 4, negative 6. All right, so that will be the form in which the equation, this is going to be the form in which the question is going to be asked to you. So we want to write an equation of a line which is parallel to y is equal to negative 2x, and it is going to go through the point 4, 6. So let's sort of picture what's happening here. If you open up Desmos, then I'm going to type in the equation here that we're given. So we're looking for y equals, our original equation is y is equal to negative 2x plus 5. And here's what it looks like. So we're looking for a line that's going to be parallel to this. So it's going to be running in this direction, but it has to pass through the point 4, 6. So if I find 4, 6, it's going to have to go through this point right here. All right. And so we're going to have to figure out, okay, I need the same slope in order to make it parallel, and I want it to go through that point. Well, the first thing, of course, step 1 is to find the slope. Well, the slope here is negative 2. Pick that out first, and then find the new slope. Well, what's the new slope going to be? Well, if it's parallel, and you're going to have to pay close attention to whether the question's asking you for parallel or perpendicular. If it's parallel, the slope is still going to be negative 2, right? So I'm going to make just a tiny note to myself. Okay, m is equal to negative 2. New slope based on parallel, what we know about parallel lines. Then we're going to use point slope form to write an equation. So y minus y1 equals m parenthesis x minus x1. And I'm going to use this point, of course. Remember, this is x1, this is y1. So I'm going to write my equation. Y minus, well, the y1 is negative 6, so that's really going to be plus 6. This is what we did last week. The slope I know to be negative 2 because it's going to be the same as the original equation. And then parenthesis x minus my x1, which is 4. All right, so I've written my equation. Now I want to solve it for y is equal to mx plus b. So I'm going to do what I did in my warm-up, and all I'm going to do is I'm going to distribute and move the 6 over in order to get y by itself. So when I distribute this, I get y plus 6 on this side is equal to negative 2x. Negative 2 times negative 4 is positive 8. And then I'm going to subtract 6 from each side, subtract it from the number, not the x, and we get y is equal to negative 2x. 8 minus 6 is positive 2. And so we get y is equal to negative 2x plus 2. Now, again, you should always be able to check yourself because you should be able to go to Desmos now. I've got my original equation in here. I'm going to type in what I just got. I'm going to type in y is equal to negative 2x, and it was plus 2. Right? Yeah, negative 2x plus 2. All right, I'm going to zoom in, zoom. And of course the point, oh, it was 4, -6. I was pointing at 4, +6 a minute ago. All right, so I just want to make sure that, is this parallel? Yes, they are parallel to each other. And the other thing is that it had to go through the point 4, -6. So can I find 4 over 4? Is it down -6? And look there. It is exactly running through the point 4. Oops, you can't see that. It is running exactly through the point 4, -6. Oh, yeah, right there it is. 4, -6. So it does go through that point, and it is parallel because it has the same slope. And so I have now found a parallel line to my original line that goes through this point. All right, now we can do the same thing for perpendicular. So now we're going to write an equation of a line which is perpendicular to y equals -2x plus 5. We're going to use that same original line. And it passes through the point 4, -6. Same exact situation. The only thing that's changed is that the question is now asking me to make a line that is perpendicular. All right, so we're going to follow the same steps. Find the slope. We did that earlier. So look at this. Look at the equation you're given. The slope is -2. So now my goal is to find my new slope. Well, my new slope I'm just going to make a note of, but since this is perpendicular, remember, what do we know about perpendicular lines? The slope is the opposite reciprocal. So I'm going to make a little tiny note to myself. I have to reciprocal 2, which means I have to flip it upside down. So it's going to be 1 over 2, and since this slope is negative, this one is going to remain positive. So my new perpendicular slope is the opposite reciprocal, negative to positive. 2 flipped upside down is 1/2. This is my new slope for my perpendicular line because it's asking me about perpendicular. Now it's going to pass through this point again, and so this is still my x1, y1. Now I'm on step 3. I'm going to use point slope form to write the equation. So I'm going to plug all my information into here, into this form. So it's going to be just kind of like last time. It's going to be y minus -6, which becomes y plus 6, is equal to, only thing now is I'm going to use this new slope. I'm going to use 1/2, and then I'm going to use x, and it's minus x1, which is 4. Now, I'm going to distribute because the last step is to solve for y is equal to mx plus b, right? So don't leave it in this form now. Now we're going to distribute, and we're going to solve it for y. So I'm going to distribute my 1/2. This side remains y plus 6 is equal to 1/2 distributed to x is 1/2 x. Half of 4, or half of -4 is, well, 1/2 times 4 is 2, and it's negative because it's a positive times a negative. And then I'm going to move my 6 over. So I'm going to subtract 6, and I'm going to get y by itself. So now it's y is equal to 1/2 x. -2 take away 6 is -8. And so we're going to type that into Desmos, and we're going to make sure that that looks okay. So the original line, again, was y is equal to -2x plus 5. I'm going to type in y is equal to 1/2. Oops, make sure the y is there. Y is equal to 1/2. I'm going to click outside to make sure my x is not under. You don't want your x on the bottom of the fraction. Make sure you click outside. And then it was what? Minus 8. Oops, turned it sideways. Plus 8. There we go. And we look at our graphs, and are they perpendicular to each other? Yes, they are. That forms a perfect right angle. And so my lines are perpendicular to, this line is perpendicular to this line. All right. So I'm going to give you 2 more, and you can pause the video. And if you want to try these yourself, I know these videos are getting a little bit longer, but that's just because, well, we've got a lot of material to cover. All right. You may be given an example where you have to write an equation and pick out the slope from point slope form in the original. So let's write equation of line which is parallel. So this one, you're going to look for the same parallel, or the same slope. Y minus 1 is equal to 7x plus 2. And it passes through the point 4, -3. All right. And then the next one is going to be write equation of a line which is perpendicular to y plus 2 is equal to -x minus 3. And it passes through the point 5, -3. All right, so go ahead and pause the video. Try those if you want to, and then we'll come back and we'll do them real quick and check them. All right, so I hope you took a second to pause the video and just give these a try. So let's go through these very quickly. Step 1 is to find the slope. And so on this first example, the slope is 7. Parallel slope is going to be the same. So my slope is still going to be 7. Here's my point, my x1, y1. We're going to fill this in point slope form. So y minus -3, which becomes +3, is equal to 7 is my slope. And then it's x minus 4. We're ready to solve this into y is equal to mx plus b form. So I'm going to distribute. So it's y plus 3 is equal to 7x. 7 times -4 is -28. Minus 3 minus 3. Y is equal to 7x. And -28 take away 3 is -31. So our equation is y is equal to 7x minus 31. Again, you can use Desmos to check yourself. So the last thing for each of these problems that you should always be doing is typing in your equations and making sure that they check out. So the original equation here was y minus 1. It's in point slope form. 7, and then it was x plus 2. Oh, I keep turning that sideways. Plus 2, that was the equation we were given, and we were looking for a parallel one, and the answer we got was y is equal to 7x minus 31, right? So 7x minus 31, and are they parallel to each other? Yes, they are. And so you should know, again, in the end, whether it checks out visually or not. All right, for this next one, we pick out the slope. Now, the slope here was a little trickier. There's actually a -1 in front here. So my slope is -1. So remember, for perpendicular, it's the negative reciprocal. Well, it's already negative, which means it's going to be positive. And this one might have been a little trickier, because what happens when you flip -1 upside down? Well, it's -1 over 1, which flipped upside down is 1 over -1, but it's going to be positive instead of negative. So your slope here is actually going to be 1. 1 over 1, because we have to take away that negative sign. So the reciprocal of -1, the opposite reciprocal is actually, of -1 is actually +1, which is kind of strange. All right, so that's our new slope. Our point is here, 5x1, y1. And so we're going to plug that into what our point slope form. So y, we got -3. I don't know why I put -3 again. Minus a negative becomes plus a positive, is equal to, my slope is going to be 1, and then it's x, and then it's going to be -5. Well, 1 distributed to anything is just itself, so this is going to be y plus 3, and it's just going to be x minus 5 when we distribute the 1. Last thing to do is subtract 3, and we get y is equal to x minus 8. And so we're going to check one more time, and we'll be done. The original equation was y plus 2. Y plus 2 is equal to negative parenthesis x minus 5. X minus 3, I'm sorry. X minus 3. 5 was in the next one. All right, that was our original equation. There's what the line looks like. And then the equation we got that is supposed to be perpendicular to it is y is equal to x minus 8. And so we look, and those are indeed perpendicular to each other. And I forgot to check for the point in this last one. Does it go through 5, -3? If we go to 5 and down -3, you betcha that 5, -3 is a point on there. If I can get it to stop. It's always hard on these devices. There we go. 5, 3, -3. Hopefully you're convinced. There it is. All right. So those are parallel and perpendicular lines. Using Desmos is a great idea to double check yourself for these problems. Make sure you're following these steps as you work through your assignments. You can go ahead and start on the quizzes and email me if you have any questions about parallel and perpendicular equations.